Hi, in this one, we're going to be going over a final example of a special case of linear equations. Now, as I've explained before, there are three types of special cases for linear equations. There's conditional, and this is where you get a situation where you have x equals something where something is like a real number. Okay, so this is where you get one single solution that's true, and that's going to be called a conditional, and this would be the normal situation. In other words, most linear equations will lead to a conditional equation. The second situation is when you get an identity, and that's where you get an infinite number of solutions. So something like 3x minus 5 equals 3x minus 5. Whatever you plug in for x, okay, is always going to lead to a true statement. That's why we end up with a situation with an infinite number of solutions. Okay. And in fact, if you solve for x, what you'll get is 0 equals 0. Okay. So this is called an identity. The third situation is called a contradiction. And this is when you get a false statement like 0 equals 5, where it's obvious that 0 does not equal 5. Okay. So this is called a contradiction. So let's go over the example. Here we have 6 times the quantity of 1 minus 3x equals negative 6 times the quantity of 12 plus 3x. Let's go ahead and start to solve it by distributing the 6 and the negative 6. And when we do that, we get 6 minus 18x on the left side. On the right side, we get negative 6 times 12, negative 72. Negative 6 times 3x is going to be negative 18x. And if we try to isolate x, you'll see what happens. So I'm going to isolate 18 to the left side. So I'm going to add 18x to both sides. And then I'm going to subtract 6 from both sides. And what you'll see is that you'll get 0 on the left side. And on the right side, you get negative 78, right? 72 plus 6 is 78. And you have a negative sign there. And what situation do we have here? We have 0 equals negative 78, which is obviously false. Therefore, what you have here in this situation is called a contradiction.